Welcome to the tutorial for exit ticket 1.06, transformation 1. Which figure demonstrates translation? Notice my images are different than your images in your exit ticket, so pay close attention to translation is a slide. That means that the image just moved left, right, up, or down. So example, this one moved or it slid translation. This is a reflection, so this flipped over a line of reflection, which is right down the center. And this image rotated. So its point of rotation is right here. It's like I stuck a pin in it and just spun it all the way around, which we call rotation or turn. Same question for number 2. Which figure demonstrates translation? We notice that A walked over this many units on the x-axis and walked down or negative this many units on the y-axis from our image A to our new image A prime. Here we have reflection, so we notice that it flipped, reflection flips over this line of reflection. We can see that B did not turn and neither did A. So if we look at line segment AB, we see that it just flipped to A prime, B prime. Next we have rotation. We do notice that, let's use this color here. We do notice that FD rotated all the way around to F prime, D prime. Okay, so it didn't walk left, right, up, down, and it did not just flip, it actually rotated around. We call that rotation. Next, student will rotate triangle. Here you've got triangle A, B, C, 180 degrees about one of the labeled points. Okay, so we've got quite a few labeled points here. We have A, B, C, D, E, and F. Student says the image will touch the pre-image at more than one point. Okay, which points could be the center of rotation? So notice that this triangle has to touch itself at other points rather than just one. So let me show you an example. If we were to rotate it about point A as the center of rotation, 180 degrees as it says, you're going to see that it is not going to touch. Okay, so notice that it doesn't touch any place on the image. It needs to touch in more than one place. So instead, let's try E. Notice E will touch. Let's try D. 180 degrees. D will also work. F will not work. It sends it way off to the side, just so that you know. So that's the idea that you're looking for. All right. Question 4. Which translation vectors could be used for this pair of figures? So in other words, translation means that I slid it. So I'm going to go from this point to this point. That's a translation vector. So you're going to see an arrow on the side that says I moved it down or I moved it up. Okay, so both of these vectors would work. If you see something like this or this, you will notice that that will not work. Here's another example. From this point to this point, it can go this direction or this direction. The translation vector is going to look the same. They may try to trick you, I'm not sure in this ticket, they may try to trick you with a really long vector. That would be incorrect as well. So just think about the point that it would drag. Here's another one. Same thing. So your vector is going to go from here to here. So that one's a little bit longer. The corresponding lengths from the point of rotation between the pre-image and image are preserved. This is true for every rotation. The angles in the image and pre-image are congruent. This is true for every rotation. The image and pre-image are congruent. This is true for every rotation. Please let me know if you have any questions or concerns about this exit ticket.